All right, guys, ready? All right, what was the key thing that you need to remember about prisms? Always draw the what?
Base.
The base. How many bases did a prism have? 2. So the thing is, don't forget the stuff you need to know. Do you need to know all your area formulas from Unit 9? Yeah, so make sure you know all your area formulas from Unit 9. Make sure you know all your stuff about right triangles from Unit 8, your special right triangles, your Pythagorean Theorem, trigonometry. All of those things are still being used, correct? They all just got applied on the very last homework assignment with 10.4. So now we're taking lesson 10.5 and we're putting it into 2 lessons. We're putting the hardest one today, all right? And it's the surface area of pyramids. Now, we're going to go through this, and I'm going to be pulling out some stuff here when we're working with it. But how many bases does a pyramid have? 1. What do we call that top where all the triangles meet? Vertex. All right, so let's make sure we have that. So the vertex of a pyramid is the point, and they say this is opposite the base of the pyramid. I like saying it's where all the lateral faces intersect. So it's where all the lateral faces intersect. Now, what is basically a lateral face? Remember, a lateral face is a face that's not a base. All right? So it's the flat surfaces that don't make the base. Well, in these cases, they all have to be triangles. They all need to be triangles. But there's also, do I still have things like lateral edge and base edge when I'm talking about these? So like if you're looking at the pyramid here, all the segments that are in black, those would be base edges, right? And then all the segments that are in red, aren't those our lateral edges? I mean, nothing profoundly different. Very easy to take from what we did yesterday with prisms, but we need to make sure we have those things down. All right, now we have 2 different types of pyramids. This is a little bit different. Kind of based off of what we did with cylinders and prisms, a lot of people want to call it a right pyramid and they call it an oblique pyramid, but that's not what we're going to call them. If you have the pyramid, which most of you would think is normal, the one on the left, that is called a regular pyramid. All right, so with a regular pyramid, here's the key things you need to know. Your base is going to be a regular polygon. So equilateral triangle, it's going to be a square. It's going to be a regular hexagon. And you know how I love regular hexagons. I like them a lot. I always ask you about them. Could it be that octagon like on the homework? Yeah, it's going to be a regular polygon. So that's why they call them regular pyramids. But also looking at this, look at the one I have here. I have my both of my pyramids I have in my hand are regular. Describe the lateral faces to me. What do you say about that? You know what? I heard it. All right, perfect. What else about them? Isosceles. They have to be set. So basically, all the lateral edges are the same, right? And they all have to be congruent to each other. So that's what's going to make it up to be a regular polygon. So the lateral faces are congruent. Let's write that out so it's readable. Congruent isosceles triangles. So probably a little bit helpful later on some of our problems that we know that they're congruent and they're isosceles. Then we have a new term. Oh, by the way, what do you call the other one? Get this. They're called non-regular pyramids. Pretty profound, isn't it? Regular or non-regular? All right. Another definition that you have to have, it's here in boldface, it's called the slant height of a regular pyramid. What is it? It's the distance from the vertex point to the midpoint of one of the lateral faces. So midpoint of one of the lateral faces, base edge, the bottom of it. This is where it is. It's that one in blue. So it's the slant height. Now here's what's really annoying about this slant height. Those 2 segments would be the same. The letter they use for slant height is a cursive lowercase l. I have no idea why they picked L. They just did. So we go with it. So the slant height is a lowercase l. Now, which means, where is that on my isosceles triangle face? To me, in my brain, it makes sense. It's literally physically on the slant of the pyramid, right? That's where I can get the name slant height. But when we're working with it, look how it's drawn. So it goes from the vertex straight down. friends, did that not just form the idea of an isosceles triangle? Isn't that the perpendicular bisector of the base? So the fact that's the case, and it's a perpendicular bisector, does anyone see pretty right triangles that just show up? Yeah. So you're going to be working with right triangles based off of your lateral faces at times, not all the time. But once in a while, you're really going to have to know that. So that's huge there. Here's a couple other things that we're going to get to in a moment, but let's get the next one down. So that's our slant height. Then we also have to have an altitude. Remember, the altitude gives us the height, right? It's the segment that gives that we work with volume, we work with surface area, lateral area with. The altitude of a pyramid is the following. It is the perpendicular segment from the vertex of the pyramid to the plane. So where would this be? Let's do that in green. Let's just have fun doing this in green. So the altitude is going to be in green. That means I go from the vertex and I go straight down. That's going to be a perpendicular segment. So this would be your altitude. Now, where does that hit on the regular pyramid? It goes back to the center, right, smack dab in the middle. It goes to the center of your regular polygon. All right, now I'm going to take you a step further because this will make a little more sense drawing it right here. So this is going to be my altitude. Do not mistake that black line for lateral face for altitude. That's going to give me my height. But guys, remember what goes from the center to the midpoint of the side of a regular polygon? What's that line segment right there? It's a little harder to see because it's flat. It's the apothem. Oh, I know. Great, right? So what does that mean? I'm going to move it down here. That means the physical height of a regular pyramid, the apothem of the base, and the slant height make a right triangle. You're going to have to use that idea in order to solve, excuse me, especially for volume. So we're going to use the fact the height, the apothem, and the slant height make a right triangle. But the other thing that we even did earlier makes sense. Draw your lateral face off to the side if you have room somewhere. Here's your lateral face. We know the lateral edges are the same. We drew in the slant height. Do you guys see the other right triangles you could possibly be working with as well? You have to be really good at knowing what's going to help you with the slant height or the lateral edge or the height by just using those right triangles. So that's one reason why I use regular pyramids. It's right triangles galore. Unfortunately, for non-regular pyramids, the altitude isn't quite so nice. So I'm going to move back up here. The altitude, again, has to come from the vertex and has to go straight down. Notice if this one goes about straight down, it's a little bit on the outside. So the altitudes for non-regular could be inside, could be outside. It just matters how they're looking at it. But remember, a non-regular pyramid looks like it's kind of looking at it, right? It's a little offset when you're looking at it. So keep those type of things in line. All right, what is all that junk in the middle of the page? Well, it's talking about how to calculate the lateral area of a pyramid. Now, look at the words in red. It says lateral area and surface area of what type of pyramids? Regular pyramids. We are not going to worry about finding the surface area and lateral area at all on non-regular pyramids. That just takes too much time because you're going to divide it into all the parts. We don't have to do that when we use a regular pyramid. So really what they were trying to show you is how to calculate the lateral area. So the idea of that, obviously the lateral area is everything but the base, right? So they use the square pyramid as an example. So they put the congruent isosceles triangles all in a line. They're like, okay, we could calculate the area of each one of those, right? The slant height times the surface divided by 2, right? Because base times height over 2. And I can multiply that by 4. Are you guys with me on that? That's one way you could do it. But what if we could do it in one formula? Well, they're showing you that you can. Notice the dashed lines. What does the dashed lines form? Did that just form a parallelogram? All right, that parallelogram, can I find the area of that? Yeah, because the area of the parallelogram, which is base times height, Well, what's going to be the base? Well, that's the perimeter of 4S. So that's my perimeter. And then what's the height? L, which is my slant height. All right, so that's the area of the parallelogram. But I want to find the area of all of those triangles. Well, look at that parallelogram. Isn't it basically just double the triangles? Because isn't this triangle the same size as this one? And so on. Yeah, because that's how we drew it, right? So they're going to be the same size. Well, what would you have to divide by then? All triangles. That's going to be PL divided by 2. Now that's how you do it. Does that make sense? So it's perimeter times the slant height over 2. Now obviously we're just going to memorize the formula so we don't have to sit there and think about the y as often. So we're just going to go lateral area, and because we have fractions more with this, we actually write it more as 1/2 the perimeter of the base times the slant height. Now someone goes, can I go P times the perimeter of the base times the slant height all over 2? And my answer is yes, you can, right? Isn't it the same thing? I just don't write it that way because I've done enough years of this. This isn't used as often. It's just because we have more fractions and stuff that we're working with. Make sense? All right, so surface area and with our lateral area. Remember, your surface area is your lateral area plus you always add your base to it. Well, how many bases does a pyramid have?
1.
So it's just plus B. So 1/2 perimeter of the base times the slant height plus the area of the base. So capital B on this one, not a lowercase b. All right, that's it for formulas. Should we go ahead and start cranking these out? All right, so let's do this together. All right, first example says find the lateral area and surface. Oh, actually, before we do this, write this. Always draw what? Is that big enough letters? I'm going to highlight it just to make my point. Yeah, I could go bigger. That's true. Let's have another one. Look, joy abounds. Always draw the base. With prisms and pyramids, that's going to be my first thing I ask. Did you draw it? If not, I'll be like, okay, I'm not helping you. Always draw it because they're not always going to give it to you otherwise. All right, so let's go with this one real quick. It says find the lateral area and surface area of a regular square pyramid with base edge length of 14 centimeters and a slant height of 25 centimeters. Okay, it almost sounds redundant, doesn't it? A regular square pyramid. A square is regular, right? What is the regular really describing? It's really describing your pyramid, right? Like what type of pyramid? I can have a square base and not be a regular pyramid because you could have, the lateral faces could be all wonky. But the fact is here, we know that it's going to be a regular pyramid, so we can work with it that way. So what's the number one thing I'm going to do? Draw the base. And since it's a square, it makes me happy because it's a lot easier to work with. The base edge, so the length of the sides of the square are all 14. I'm going to do the same thing that I've done before. Find the perimeter. So it's 4 times 14 equals 56. Guys, anytime you use an area formula, you need to write it down. So what area formula are we going to use for the area of a square? BH? Yes, BH or side squared. Am I going to get the same result? Yeah, I don't care if you use side squared or base times height. You're going to get the same thing. You're going to get 14 squared here, or you're going to go 14 times 14. And either one's going to give you one what? 96. So this would be centimeters. This is square centimeters. I don't really need to label those because we're not done with the problem, but it just helps us keep track of things. So now you just write your formulas down and plug out your answers. Have your calculators out today if you haven't brought them out already, because we're going to have a lot of large numbers, and I want you to be able to do the calculations for them. So with this one, lateral area is just, I'm doing the wrong formula. 1/2 the perimeter of the base times the slant height. So I get 1/2 the perimeter of the base is 196. And my slant height, they told us, is what, guys? Yep, 25. See why I'm having you do this and not myself. And what did you guys get? Yes, ma'am. Oh, excuse me. I put the wrong one in. Thank you for catching that. Thank you. 56. I put the area formula in by accident. Good save. right, so what's 1/2 of 56 times 25? It's just to be even number, right? 700 square centimeters. Catherine thinks I'm catching that. Surface area is just our lateral area plus the area of the base. So 700 plus 196. Shouldn't that be 896 square centimeters? Isn't it very similar, Phil, to what we did yesterday? It really is, because I'm just doing the basic setup the same. I have my formulas for perimeter and area of the base, and then I would just plug and chug into my formula. That stuff won't change. Won't change. All right, let's look at the next one. It says, find the lateral area and surface area of the regular pyramid. Talk to me. What do you know? It's a what? We have a hexagon for the base. Good. What else do we know? We know the slant height. Awesome. And we also know what? Base edge. So guess what I'm going to redo? I'm going to draw my base. Not a pretty hexagon, I know, but it gets the point across. All right. So I know all of these are 10 inches. Guys, don't I need to know the perimeter for that? Isn't that going to be 6 times 10? So I got 60 inches, right? So I'm going to have 60 inches. Now, that's a hexagon. What formula do I need to use for its area? Yeah, apothem times perimeter over 2. Which means then I have to draw my central angle triangle at this point. I need to draw in my apothem, and I know my apothem bisects my side because the apothem goes from the center to the midpoint. What else do I need to do? Know my central angle. Okay, by now, all of you probably know a hexagon central angle. What is it? 60 degrees. So that means from here to here is 60 degrees. So 360 divided by 6 is 60 degrees. But what does the apothem do to it? Now I have a 30, 60, 90 triangle, and I need to find the apothem. What side of that 30, 60, 90 triangle do I know? Short leg. Which one do I need? Yeah, I need to get to the long leg. So we're going from short to long. Do I multiply or divide? Multiply. So doesn't the apothem become 5 root 3? I like it when the numbers are easy at least, right? So it's 5 root 3. Now I can plug in what I know. I get 5 root 3 times the perimeter of 60 all over 2. Guys, what do you get for that? All right, now I have perimeter of the base. I have the area of the base. Can I take the time and solve for my lateral area and surface areas? So we have all the stuff that we need. So that's good. So let's write our formulas down. All right, who thinks they already have it memorized? Go for it, Devin. Come on. Yep. So 1/2 the perimeter of the base times the slant height. Very good. So, and the other thing when you're memorizing these, you notice I normally don't go 1/2 PL. I normally go 1/2 perimeter of the base times the slant height. I'm putting what the letters represent in my head at the same time. So memorize it, obviously, because you know I'm going to want you to know them, but make sure that you also know what they represent. So our perimeter of the base, isn't that 60? Our slant height, they told us, is 16. Someone do the math for me real quickly on that. What do we get for the lateral area?
40.
Yep, awesome. So 480 square inches. Our surface area is just the lateral area plus the area of the base. So I get 480 plus 150 root 3. Question. Yes, just be careful because a lot of times fractions are involved. So you're totally okay doing that as long as it's easier, if it's better use of it. I'm the type of person, I fluctuate between them. If you guys saw that when I did it with triangles, sometimes I go base times height over 2, and the other ones I go 1/2 base times height. It matters if I have fractions in it or not. If it's fractions, I'm not going to go base times height over 2. That's too much work. You guys did that on your test. when it would have been easier to not put it base times height over 2, a lot of you did. So it's little things like that when we go over your test later, you'll see. But are we good with this? Pretty simple, right? So how about if I just mess it up on you now? Let's have a little bit of fun on the next one. All right, it says find the lateral area and surface area of a regular triangular pyramid with base edge length of 6 feet and a lateral edge of 3 root 10 feet. What do you know? No base edge length? What else do you know? Lateral edge. What don't you know? Slant height. Right? Lateral edge, is that the same as slant height? Guys, look at the little pyramid I have in here. Lateral edge, is that the same as slant height? Lateral edge is too long. Because if you're looking at that triangle with the hypotenuse, look at that. The slant height's the leg and the lateral edge is the hypotenuse, right? So we're given lateral edge, not slant height. That ruins it when we're even trying to look for lateral area. But what's the other thing I know? You guys didn't tell me this. I was hoping you'd tell it to me first. What? The base is a triangle. Be more specific. It's going to be a regular triangle, so it doesn't that have to be a regular polygon. So my base is going to be an equilateral triangle because it's a regular triangle. And we know each one of these is 6, so that's great. What's the perimeter of my base? Is that 3 times 6? If I can write it here. All right, guys, what's your area of the base? What formula are you going to use? Yeah, it's easier to use side squared root 3 over 4. It's just a time saver, isn't it? So when you do that, that's 6 squared root 3 over 4 equals, well, that's 9 root 3. Because 36 divided by 4 is 9, and the root 3 comes along for the right. Drop the radical 3 because that kind of messes up the problem. All right, so I've got my base. I've got the perimeter. What's the one thing that's missing? Slant height. So how about if we draw a lateral face here to give us another visual? This is what we know. We know this is 3 root 10, this is 3 root 10, and this is 6. What do we need? Slant height. What is that slant height? Wow, that sounded great. What is this slant height? What point does it go to on the base? Midpoint. So isn't this true? So now can I use the Pythagorean Theorem? Aren't you guys so excited, right? Pythagorean Theorem. So slant height squared plus 3 squared equals the quantity 3 root 10 squared. If you forget the parentheses, and especially if you put in your calculator, you're going to get this wrong, so get in the habit of using your parentheses. So slant height squared plus 9 is equal to what? It's going to be 90, right? Because 3 squared is 9, the square root of 10 squared is 10. So 10 times 9 is 90. All right, so my slant height squared is 81. Oh, look, a nice number at least. So my slant height is a positive 9. A little bit of work, not impossible, but the moment they say lateral edge, think like this type of drawing with your lateral face. It makes your life a lot easier. Makes it a lot easier. All right, let's go for it. Lateral area. 1/2 the perimeter of the base times the slant height. So 1/2 the perimeter of the base. What did we get that to be earlier? 18. Our slant height is 9. I got 81 square feet. Surface area is just your lateral area plus the area of the base. So 81 plus, well, the area of the base was 9 root 3. Guys, can I combine those at all? I'm not lying. Every year I'll have someone tell me that's 90 root 3 when it's not. Those are not like terms because of the radical. You should just sit there and label it right now because everything's in simplest form. That should be in squared feet. Right here and here. Surface area and lateral area. What do you guys think? All right. Do you think it's okay if I say let's skip a problem? Are you guys good with that?
Yeah.
Just right here, see notes. See filled in notes online is all you have to do. Does that make sense? We're not going to put this on the video. It's one of those that's good and is a thought-provoking one, but we really don't have time to do. All right, The next one. I like how it says it's pictured at left. Is it pictured at left? No, it's not pictured at all. So just cross that word out. All right. So the Great Pyramid of Giza at Giza, Egypt, was built about 2,580 BC as a final resting place for Pharaoh Khufu. At the time it was built, its height was about 481 feet. Each edge of the square base was about 756 feet long. What was the lateral area of the Great Pyramid to the nearest foot? Guys, definitely need a calculator for this. But what's the one thing I know I should draw no matter what? The base, which is a what? So here's our square. I think they said 756 all the way around. All right. Now I'm looking for lateral area. So over here in the back of my mind, what am I looking for? I need to know perimeter of the base and I need to know slant height. So the cool thing is, do I have to waste my time finding the area of a square this time? No, I just need to find the perimeter first. So I'm going to go, all right, the perimeter is just 4 times 756. It should be a nice large number. What did you guys get for that? All right, great. Now, what else did they give us? What else do we know? Height. Is that the slant height? Did I talk to you at all about how the height is related to the slant height anywhere in our notes? Yes. Go back to that first page. See a triangle right here, right above the notes? Do I know the slant height, the height, and the bottom of the base make what type of triangle? A right triangle. So now let me scroll back down. Hello, too far of a scrolling here. So that means I'm looking for the slant height. So I don't know, but I know the height was 481. Oh no, I still need to know the apothem. Well, I'm going to draw it in. I heard something. What? Yes, it would. The apothem, isn't that, if I was to extend it, wouldn't that make the whole side? So why not just take 756 and divide it by 2? So whatever 756 divided by 2 is, what did you guys get? All right, so 378. Great. I'm going to put 378 on there. Now, what awesome theorem have you been using all semester that we could apply one more time? Pythagorean Theorem. Isn't that amazing how it's still there? And what's really amazing, you want your calculator here, because I'm not going to yell at you as much about for simplifying as much, because the numbers are huge. All right, so I get here 481 squared plus 378, oops, make sure I write it correctly, 378 squared equals my slant height squared. Someone do this quickly on the calculator for me. What's 481 squared plus 378 squared? So 374,000 what?
240.
I mean, that's just everybody's favorite number. Especially if you're in math, right? So then you take the square root of both sides. Now here's my comment to you. Do not waste your time simplifying that radical. Because look at what the directions say in the homework. Most of the time I'm like, no matter what, get in the habit of simplifying your radical. Does anyone want to try to simplify that radical right now on their own? No.
Okay.
All right. So what the cool thing with this one is, because I'm asking you to round to the nearest foot anyway, is it going to be okay to let our calculator do the work? So yeah, so let's just plug it in. 1/2 the perimeter, which is 3,024, times the slant height, well, that's the square root of 374,245. Punch that into your calculator, and yes, it should be large if you did it right. And tell me what to the nearest square foot is the lateral area, basically, of that pyramid. So 924,975 square feet. I mean, that's everyone's number that they pick all the time, right? See why we didn't simplify the radical now? Now, most of the time, should you? Yes. But let's go be realistic on this one. We're approximating the the lateral area of a pyramid. Not going to be quite as important. All right, now, while I am passing out your test, I need for you guys, most of you are almost finished or have this down. Again, look what we're doing. It says find the surface area of a regular square base pyramid with a base edge of 10 centimeters and a lateral edge of 13 centimeters. Right away, what's missing? Slant height.
Yeah.
So we're missing slant height. But the one thing we know, let's go ahead and do every single time, draw your base. The nice thing is they did a square again, which we kind of like those, with a base edge of 10. Well, I need to know perimeter. So we know that's going to be 4 times 10, so that's going to give me 40, and I think it's going to be in centimeters here. The area of the base, I'm just going to go side squared, or base times height, same thing. So we get here, oops, should be a 10 squared. I can't seem to write all of a sudden. And that's going to be 100 square centimeters. But the problem is we're missing the slant height. But what did they give you? Lateral edge. So that means we're going to use the idea of the lateral face again. We know this is 10. Both of these are 13. I need the slant height. Let's do that in green or something like that. Did you see what I gave you? It was a triple, right? At 5 what? 5, 12, 13. So now I know my slant height is 12. So it's a triple. If not, could you use the Pythagorean Theorem and solve for it that way? Definitely. So then when we're doing this, now you just have to plug it into your surface area formula, which is 1/2 the perimeter of the base times the slant height plus the area of the base. So 1/2 the perimeter of the base was 40. Our slant height we found to be 12. The area of the base, 100. So what do we get with this one? So 1/2 of 40 is 20. 20 times 12 is 240. Plus 100. Did you guys get 340 square centimeters, or we're pretty close to getting that? All right. Marking up diagrams, drawing them up. Nice thing is almost everyone on there, since it's a worksheet online again, make sure you just mark it up, but redraw the what? I want to see the redrawn base. Excellent. All right, good